In this video, we'll be looking at the relationship between the sides of a triangle and the segments formed from an angle bisector. Here we have just any generic triangle. I can change it and you can see that it's nothing special. What I'm going to do is construct an angle bisector. I'll construct it at this vertex right here. So we need this angle, and I'm going to construct the angle bisector. Okay. Now I want to measure this side of the angle that I bisected. So I want to measure the distance here. And then I want to measure the distance on the other side of that angle. And then the relationship is for these segments that are formed. So I need the point of intersection for these two line segments. So let's construct their intersection. And then I want to measure this segment, which is associated with this side. And let me measure that distance. And then let me measure this distance, hg, which is in a ratio to this side, fg. So measure that one. Now the thing is, we want to look at the ratio of this side, EF, to this segment, EH. So let me do that calculation. So EF divided by EH, that ratio is 2.86. And then let me also look at the ratio of this side, FG, divided by HG. And you'll notice that these ratios are equal. So this side of the angle that I bisected in a ratio to the segment adjacent to it compared to the ratio of this side of the angle that I bisected to the segment adjacent to it, which is HG. Now if I move my vertex, keep an eye on these ratios, notice that they're always the same. Notice that HG, which is right here, from this point to this point, is 2.88, and HE is 3.42. So those segments are not equal, but the ratios are. So we have 4.49. So I can move this, keep an eye on these ratios, they'll always stay equal, and keep an eye on these segment measures. Rarely are they equal, and in fact the only time they will be is when the triangle is isosceles. And so we almost have an isosceles triangle, but it's not always going to be that way.